Hello, and welcome to another episode of Hacking with Friends. Today I have my friend Adrian Sambria. Did I get it better this time?
Sanabria.
Sanabria! I'm sorry. My friend Adrian Sanabria from Thinkst Canary, from Thinkst, who's going to walk us through some really interesting examples of using Thinkst Canary tokens. Can you tell us a little bit about what these are in case people missed our podcast episode, which they should definitely check out, by the way?
Yeah, sure. Yeah, so we've got a bunch of different examples here. And actually, let me see. You're not going to be able to see what I'm doing, though.
Oh, just go ahead and share your screen.
It says it's disabled.
Oh, that's because Zoom has this awesome new thing that makes it so that only the host can do that. But don't worry, you can now do it. I just enabled it.
Okay.
By the way, new Zoom users, that's a fun new feature, huh? There we go. So for anybody who's new to this or did miss that podcast that we did, the reason I love Canary tokens is, for one, they're free, and for two, they are infinitely reusable, and there's so much creative stuff that you can do with them. So I'm really excited to see some of the ways we can actually be practical about using these tokens to catch attackers in our network, or basically trigger some sort of alert for a suspicious action. And some of these are really clever.
Yeah, so Canary tokens are really, really handy. So we've got, there's a couple things that we do at Thinkst, and one we make the Canary, a lot of people are familiar with, which is a device you put on your network. You make it look like a real thing, but it's not a real thing. It's only there to catch attackers, and if somebody tries to mess with it, log into it, they get busted. They get caught as soon as they start trying to log in or scan it or anything like that. No normal employee should be using those devices because they're not real devices. But not all attacks happen on the network. So what we've got as well are Canary tokens. And Canary tokens can be a lot of different things. Most people who are familiar, somewhat familiar with Canary tokens, are either familiar with the concept of a file that when you open it, it sends off an alert. That alert triggers, or a web bug, what you call a web bug. So this is a similar technique to how marketers know that you've opened their email when they send out their email campaign. You know, they either have like a 1x1 pixel in the email, or they use some other method to know that you've opened that email. So these are some of the same techniques that we can use with Canary tokens to know when somebody's been somewhere that they shouldn't be. And the idea is you take these, you embed them in highly sensitive places or sensitive documents, and then you know somebody's in there that shouldn't be.
So I really like this because it basically is the concept of a honeypot, but instead of trying to spin up something like a Kippo honeypot or something that kind of like hilariously traps attackers in something that looks like a real system, that takes something a lot more than just a basic person's experience to set up. This is something where anybody can just pop up something that works right out of the box, and it's cool that you can use the concept of a honeypot in a way that's so simple that any beginner can use something that usually is something that hackers or IT people would only have access to.
Yeah, exactly. And with Canarytokens.org, which is entirely free, you don't even have to create an account. You can just drop in an email address or a webhook here. And this is how we're going to notify you that your token triggered. You know, so this particular trigger, let's say I'm going to create a fake email to put in my inbox, and when somebody visits it, it's going to tell me exactly where that is. So this part is super important. And this is the number one mistake that I see people make with these tokens, is that they're not descriptive enough on where they put it. In this case, I actually have more than one inbox. I've probably got 10 email accounts, so I don't want to just say Adrian's inbox. I'm going to say Adrian's Proton Mail inbox.
So during
Adrian's
our podcast, I mentioned that I really like to use Canary tokens to, again, like specifically label them so I know when a file has been accessed or someone has opened something. And one application I found was putting them on a USB drive and seeing if anyone happened to open any of the files on that USB drive. So for me, if I forgot to put a label on where that drive had been, I would have no idea. I would just know that someone had opened something of mine. And if I hadn't set a good label, I would just be like, okay, something got opened. And I wouldn't know maybe where I placed it or what the file was. I wouldn't get any information back.
Totally. Yeah, that's a common problem is I've seen people create a Word token and then deploy it to 500 laptops. and then when it goes off, you have no idea which of those 500 that it's on. So just to demonstrate this in its most basic form, so yeah, this isn't the most sneaky thing in the world. It's got Canary tokens in the title. But the cool thing about Canary tokens is that they're not always going to be visible to the attacker. Like in this case, when I create my fake email, it's going to be an HTML email, and I'm going to have a link in there, and they're going to click that link. And by the time they're seeing this, it's too late. They've already visited the website, and we've gotten our alert that it's been used. It's been triggered.
So I have a question. Is it at all possible to ever have that link back to anything aside from the blank Canary token page, or is it always going to link back to the Canary token endpoint rather than forwarding the attacker on to another page?
Right. So we actually have some cool stuff for that. We've got our fast redirect and our slow redirect. So like for one example, and basically it's going to do the same thing. It's going to go that blank page, but only for a fraction of a second before it forwards, it does a redirect to another site that you tell it to redirect to. And one of my
like Bitly and those sorts of services that shorten URLs work, right?
Yeah, exactly. Yeah, same deal. And when you have that stop in the middle, that first URL you go to, that's where we can actually grab some details from the browser, some information about the attacker's environment, and we can take a quick look right now, actually, at what that looks like. So you can see here, obviously I'm using Mac, I'm using Chrome, you get some versions there. So the user agent is pretty helpful in just generally understanding where the attacker is coming from. If we click this link for more information, we can now see...
Oh, cool.
We do a little bit of enrichment here, and you can see that I am indeed in Knoxville, Tennessee, and I'm using AT&T. And if I were coming through a VPN, I could make it look like I'm coming from anywhere, but in this case, I'm not. So this is at my actual location.
What's the MIME types?
Yeah, the MIME types, this is just stuff that you get out of the browser, so how it handles different types of files.
So just different ways you might be able to fingerprint a browser that might be trying to disguise its other details, like using a VPN or going through a Tor endpoint. I see there's also the ability to detect if someone's using a known Tor endpoint. So maybe if all the other details look crazy, if that flag is triggered and says, hey, this is a Tor endpoint, you know that it shouldn't be trusted. It's someone who's throwing their location around in Tor.
Yeah, so I can actually simulate that. The newest versions of Brave actually have an option where, how you've got incognito mode in most browsers. They have a Tor mode. So let me kill that tab from loading. Just going to pull it over onto my other monitor to hide my my personal stuff. New private window with Tor. Okay, so now I've got a browser window that's actually coming through Tor. I can take the same token that we had before. Actually, let's go ahead and use the redirect one since we were going to create this anyway.
Cool. So in this scenario, an attacker might find a link that says that it's to some sort of really sensitive file. Maybe it's shortened with like a bit.ly that like hits it before it goes here, so it doesn't say Canary tokens in it. Would that still work?
I'm sorry, say that again.
If you were trying to disguise the Canary tokens part of the link, could you put it through like a bit.ly link or something else to kind of disguise it first before?
Sure. Yeah,
cool.
I mean, as long as it visits that page, really all we're looking for and we'll break it down here as I paste in this link here. So this bit on the end, you can change to whatever you want. And this bit before this long random string that you see, you can change that to whatever you want. You can also run your own Canarytoken server. You can go to our GitHub. You can grab a Docker for it and just roll your own on whatever domain you want. So all of this, except for this, can be modified.
Cool. So on my local network, if I wanted departmentoftoilets.gov to be what's basically receiving these alerts, then, which by the way is what our local DNS server at home is set to, then maybe that would be a way to trigger it without having anything going outside my network at all.
Exactly. Yep.
Cool.
Yep. So yeah, we forward them on to Okta. I use this on a lot of the scenarios that I cook up because it looks pretty believable. A lot of people use Okta for single sign-on. So yeah, why not throw them over in that direction there?
Nice.
And then when we take a look at our our mails here. Okay, yeah, we've got a second one. This, let's see. Yeah, so this is number 2. So let's grab some more info on that. And now, coming from Amsterdam, from Harlem with an extra A. It's not the Harlem I'm familiar with. And then exit node is true in this case because yes, I did come from an exit node. You can see it. I mean, it's pretty obvious. It's right there in the host name.
So, are there any other additional details it captures? Like, there we go. The keyboard language. So it's set to English. Does it record the time zone?
The time zone, I don't know off the top of my head.
Just curious, yeah, because I'm wondering if an attacker was using Tor, what details are really leaking through here? The fact that they're using a United States English keyboard, that's like a really important clue, seeing as we're coming from the Netherlands and we know that it's a Tor exit node. So,
the real focus,
to see, like, what's leaked.
Yeah, and the real focus here for us is not so much giving you as much information as possible to track down the attacker and identify them and send the police after them. It's more, crap, somebody's in my inbox, I need to change that password. or why didn't 2FA keep them out?
It's still impressive though that even using the a Tor browser and thinking like, all right, all this is going to be randomized, we can still see through it at least a little bit. We still can kind of tell that you're in the United States, even just with this kind of a quick redirect.
Right. Or it's believable maybe that the moment you see that Tor exit node, it's a Tor exit node. Where I'm physically located is just kind of completely up in the air. But sure, you can see that. My language, I didn't mask my user agent, you get some information from that. And yeah, these are all things that you can fool, you can mask, you can tweak the browser to send whatever you want because you control the browser.
Right.
But maybe it's not an attacker you're after, maybe it's, an insider, there's all kinds of different situations where you're not always after the most sophisticated criminal ever, right?
Mm-hmm.
So yeah, this can still be useful, and we let you download it in a few different formats here. But most of the information you need will be right here in the email.
So I'm curious, for people that are into like Python and stuff like that, is any of this scriptable? Like, can you like deploy Canarytokens like with a script or in an automated way and like monitor when they're triggered, or is it mostly through the web interface?
Yeah, so it's mostly going to be for the free version through the web interface. Once you get into the commercial version, we've got a full API for that, and that's where I spend most of my time. So forgive me, there might be a few features here in the free version that I'm not aware of, but it's pretty flexible. A lot of this is open source. You can jump onto our GitHub and kind of explore some of the stuff that we've got there. We've got a bunch of repos for doing different things with the both the open source stuff and the commercial stuff. So this is where I put my scripts for the commercial stuff, and you can get an idea of some of the stuff that you can do there. And we've even got customers that donate scripts back to us.
That's nice.
One of the use cases is every time somebody logs on to the Windows domain to Active Directory, they've got group policy set up to create and deploy a token onto that system. So they can automatically get a token on every host as they log on to the network.
Rather than creating one token and then putting it on all 50 hosts. That's very clever. That's very clever.
Right. Yeah, you wouldn't want to have to manually create 3,000 tokens if you've got 3,000 hosts. What you're going to do is you're going to automate that.
That's super cool.
For personal use, generally, the free one is fine, and we actually have a lot of folks on the commercial side, like working in enterprises, using the free version of these tokens, and that's fine also.
So you showed me a write-up about some really interesting applications of this. And one of them, I think, for the classes that I'm teaching on advanced human interface devices is probably actually going to replace the current one that I'm using, just because, A, it can stand up to more traffic that's automated, which in my case, when we sometimes use Grabify, it'll go down and not be able to respond to all the automated traffic. We're generating with a class of maybe 50 people. And another thing is it uses DNS. And I think that's really clever because there's some situations where you might not have the ability to actually access the internet and have bidirectional communication. So being able to tunnel out to DNS, I think, is really cool. And not everybody has a DNS server, so the fact that they can create a token that uses DNS really opens the door for some super clever payloads. I was wondering if on the basis of trying to create a human interface device payload, maybe something that is reporting back some information about a user or just a vehicle for stealing information. Are there ways that we can use Canary tokens to exfiltrate more data than just something about who clicked on it or who opened it? Is there a way to do maybe the result of a system command, or use something like the user agent or the referral link or something like that to actually bring a little bit more data to the equation and kind of enrich what's coming out of the host when you trigger one of those tokens?
Yeah, absolutely. So yeah, there are a few different techniques you can use to smuggle additional data out. So yeah, obviously when they come to our web server, when you're clicking some of these links that I'm creating, when the attacker clicks those, they're coming to the web server and the browser's handing off all kinds of information, and we can run extra JavaScript. But what about these that execute behind enemy lines, somewhere where you can't see, like you mentioned, maybe there's no outbound HTTP, no outbound HTTPS. So sure, yeah, we've got a DNS token. So you could totally create a DNS token, and we can get quite a bit out through the DNS token, because basically what we're doing is using DNS text records, which can be pretty large. So you can just... So there's a base here. Let me go ahead and create one. I can show you what I'm talking about.
And so an interesting scenario here might be you lose a piece of equipment, or a piece of equipment goes, or a piece of equipment's decommissioned, and then somebody accesses a part of it later, like beyond when you have control over it. So a lot of what we talked about is kind of honeypots for your devices that you have right now. But let's say you were going to be getting rid of a bunch of hard drives. I mean, if you had a couple seconds before you seemingly erase stuff, put something on the root directory that maybe would be tempting for someone trying to recover that data to open, it would be pretty unsettling to suddenly get a ping back from that server or hard drive that you decommissioned, and then find out that someone else is in it, actively accessing it beyond when it was decommissioned. So something I thought was fascinating is just the ability to maybe take a peek into whether someone's looking at your data after the life of your physical devices, because I never really thought of that as an application for these sorts of scripts.
Yeah, so yes, say take that scenario, you've got a server or a hard drive for a server that you're decommissioning, and you just jump into the boot script of that. And obviously you're going to want to do this after networking has come up in the boot script. And you're kind of banking on the fact that the attacker has connected this to the internet in some way. So obviously most of these aren't going to get anywhere if they're not connected to the internet, if somebody's paranoid enough to not connect them up. But with Canary tokens, you don't worry so much about the if. You just scatter a bunch of them about, and that increases your luck, just by using as many as possible. So you don't worry too much about getting any one canary token perfect. You just use enough of them that the attacker is you increase the likelihood of tripping on one or something like that. And
right, because they're free. Right. So like maybe put one in the startup script, and then one on a file that looks really juicy that they might transfer to a computer that does have internet access, and then one to maybe a very easily breakable encrypted file that has a lot of information, including this link that's supposedly to some really juicy information. All of that, like 3 different layers, might dramatically increase someone's ability to catch someone who slips up once, but is really careful the rest of the time.
And like my fake email example, like that email could not only have an HTML link in it that goes to a token, but I could have a file attached to it that's a token. And if you open that file, there's another token in that Word doc or PDF doc file. So like one of the tokens we have are AWS credentials and Slack credentials. And those are really tempting. You find those anywhere, and if you understand what you're looking at, you realize a set of AWS credentials could be somebody's entire data center in the cloud. So you've got to use it. That's not something an attacker who's after you or your company or you personally can reasonably ignore. So we can take this.
That makes sense.
Yeah, we can take this DNS token, and you'll note, again, just like the web link, this is the key part here. So we've got a database on the back end that's basically connecting this to the memo that I put in and the email address that I put in. So we know when we see somebody do a lookup on this DNS address here, which I think I had, let me find my terminal window. So if we were just to simply do an NS lookup on that address, we're going to get an email. That's going to trigger an alert. And the reason that works, and that'll work from any network with functional DNS, is because we're the authoritative DNS for this, for the root here for Canarytokens.com, so it will make it back to us. And because DNS is very latency sensitive, it's very, very fast too. So you'll get that, in a second or two.
So one scenario I think is really cool is that if you're on a guest network that you haven't provided the password to yet, or if you're on one of those Google Starbucks networks where you have to go through and accept the terms before it connects to you. In a lot of cases, that DNS request will still get through. Even if the person isn't able to connect to the normal internet, it'll still attempt to resolve a DNS query. It just won't return the result. So I've heard really crazy cases of people being able to make open source trackers by calling back to a DNS server through these sorts of free internet sources that are just scattered everywhere that don't actually provide bidirectional internet, but you can still send a DNS query with certain information in it that will get to where it's going, which is pretty cool. DNS tunneling is really interesting and weird.
Yeah, so hotel Wi-Fi, like any of those that have the captive portals, the Wi-Fi in an airplane, DNS still has to work, for you to even be able to get to the page where you have to pay for internet, right? So to get past that captive portal, you already need functional DNS, so it usually works. And
so the example I'd heard was somebody took a GPS receiver and connected it to like a microcontroller with Wi-Fi, like an ESP8266, and then stuck it to someone's car and had it drive around, and anytime it saw open Wi-Fi, it would connect and quickly send the DNS request with the current GPS coordinates as part of the string that was encoded to go to the DNS. So they were able to decode the location the car was going to, even though it didn't actually have a traditional data connection, which I thought that blew my mind, that you could make, just by using a DNS token like this, you could make an open source kind of tracker anytime that thing was in range and had the ability to query DNS. So that's pretty amazing to me. I didn't know that was even possible.
Yeah, and it's because a DNS request is so inexpensive. It's so small. It's such a tiny amount of data that you need to send out that, with microcontrollers and very, very light environments where you don't have a whole lot of computing power, it works just fine. Usually, like when you're just getting started with some of those embedded chipsets, the networking demo they have you do is like a DNS lookup or something like that, or you just ping a web page or something. but yeah, across the country, I've not tested this, but I imagine it would work. Where you know how Comcast has that open network, open Wi-Fi network for all
Yeah.
customers.
Oh, yeah. It looks like municipal Wi-Fi, but it's actually just they piggyback it on commercial Wi-Fi packages. So businesses all over the country will just get this Wi-Fi router from Comcast that actually secretly also creates a guest network for Comcast customers. And you can probably tunnel out via DNS with that because it's open, huh?
Yeah, and that's what I'm thinking. And they're everywhere because if you're, and like you said, businesses as well, you know, and that's the idea here is that's an additional benefit of being a Comcast customer is you can jump on the internet through anybody's router.
Mm,
So
that's
those
very
things,
sneaky.
I forget if it says Xfinity, you know, they might have changed it when they rebranded, but do any kind of war driving and you'll gather hundreds of them.
Wow. Wow. And any of those could be a relay point for one of these DNS-based beacons, which is pretty cool. I mean, I imagine you could even, if you really wanted to, create a script that just looks for open Wi-Fi networks periodically, briefly associates, sends that DNS request, and then disconnects. And it would basically be a way of leaking someone's location or continually pinging, even when somebody was avoiding connecting to Wi-Fi or in between connecting to Wi-Fi networks, which is creepy. And I like it.
Yeah. So this whole idea of triggering a token on purpose, you know, I think early on what we're talking about is setting traps for attackers where they're directly interacting with the file. We've created a Word doc. When they open it, it triggers a PDF. When they open it, it triggers. We're social engineering the attacker into clicking a link in an email, opening an attachment in an email. You know, so it's kind of like reverse social engineering there. But this idea of triggering it in the background when something happens, you know, is kind of a different different approach, a different way of using it, because the attacker is never going to see it. It's embedded within a script somewhere. It's the action they took was booting up the server, you know, on the old hard drive or trying to recover the data, or maybe trying to log into something and you use a login script. So you're taking advantage of these situations where a script is going to do something automatically already, and you token in there. So I can create, say I've got a Linux server, I can create a token that just runs if somebody logs in with this account, and I'm going to just leave the credentials for that account laying around for somebody to find, right? So somebody finds those credentials, they try and log into it, and so this is one I've actually got hooked up through my one of my the commercial side of things. I was going to only show the open source stuff, but this is pretty cool to show. It's something I really want to show because I've already set up all the scripting and stuff like that, so it's pretty neat.
Okay, cool.
Let's see. This is my kind of mad scientist home here. You know, this I've got several different ones. Some of them I do demos on. Some of them I just play around with stuff on. And this is what the commercial interface looks like. But I've got several tokens in here that do some interesting stuff. And we need this up to see the results. So I set up a Linux server that actually listens for SSH on several ports. Two of those ports are easy to find with Nmap. You know, so, and I've already, so that's actually an alias you can see up in the title bar here. I'm SSHing in there using a SSH key, and this is something I'm running in AWS. And it let me in and ran the login scripts, but then booted me back out. And so you can see here we've got an alert, and basically what's happened here is I reached out and triggered this alert on purpose, and I'm using the user agent to smuggle out some data there. So we can see what username they used, we can see the host name of the system, and we can see where they came from. And this is all stuff I'm just grabbing from a script. And if you use curl-a, you can put the user agent in quotes and smuggle out whatever environment variables you want or any data you're piping into that command, and just use this user agent. Now, I've actually not checked to see how much space you have in a user agent, but it's a decent amount of space to get data out.
So the thing I kind of wanted to try, if we have time, is in your example, I think you aliased something so that when, I think it was like Netcat or Nmap, so that when someone ran it, it would do the thing it was supposed to do, but it also did an alert with a fair amount of context. Is there any way you could just show how to write that payload, or just like do an alias that way? And could you make your screen screen size a tiny bit larger, just the text?
On which one? The terminal?
Yeah, the terminal.
Sure.
Sweet. Thank you.
Yeah. So we can let's just take a look here. Actually, let's do this so we can still see the alerts in the background there.
So my immediate thought on this is that I just wanted to alias my sudo command on my Mac to just like go through Canary token and then just change my real sudo to spudo. And then just every time I need to sudo something, just type something slightly stupid and different. And then anybody who jumps on my Mac and tries to run a script or something and sudos something, it's just gonna be like, I'll do it, but I'm also going to tell on you.
Yeah, exactly. Yeah, and you totally could do that. So so the way I've set this up, like I mentioned before, I'm actually running SSH on 3 ports. 2 of them are easy to find with Nmap, and they will boot you out, and they will give you this message. And this is kind of the icing on the cake. This is a redirect token that will take you to Okta login. So you're just going to trigger another alert if you fall for this here.
So that's just like a trap within a trap. It kicks you out, and then it says the reason you got kicked out is because you didn't go to this link yet, which then tracks you further.
I think that's the right port. Yeah, so that's the port that actually lets me in without setting off an alert. So that's how I get in there and mess with it and set things up. So, so yeah, if we take a look at what I'm doing here, I believe... Let's just take a look at bash rc. Doing most of it here, I think. So there's our alias. You can see the alias for netcat there is actually going to this script in .local bin nc.sh.
So you could basically take like dangerous programs or like programs that like might be used by an attacker or that are very common to be used by an attacker and alias them so you just know when someone's running them, if that's just something you want to know about.
And that's the whole concept of canaries and all this deception stuff in the first place is you control your environment. You don't have to make it easy on the attackers. You know, if you think about it, all attackers have to have some knowledge of what you're doing before they get in there. Otherwise, it's going to be really tough for them. They're depending on you using defaults and not changing the way things normally work. So if you leave all the defaults, sure, they're going to have an easy time. Their payloads are going to run every time. But if you start moving stuff around, renaming things, they're just going to think like they're losing their mind, and not only are you going to be setting off alerts all over the place, but they're just going to get confused. They're more likely to give up in their attack. And look for lower hanging fruit.
Well, all right. So you have then the command actually triggering a bash script. What does that bash script actually do?
Yeah, so there's a couple things here. We saw the alias going to nc.sh. And also we see at the very bottom here, I'm sourcing another script in the .ssh directory. And I'm just putting these in some of these hidden directories just to make them a little bit less obvious. It's not... anybody who's searches around enough would find it. But the whole point here is they never get an interactive shell. They're getting booted out right when they get in. And even if they do get in, there's a lot of trapped processes here. So if we take a quick look at this, what was it? Yeah, rc.sh. Very short script. Basically what I'm doing here is setting it up so that SSH client actually creates an environment variable that tells me where somebody's SSHing from and on what port. So I can see if they come in on anything other than the correct port, I'm going to boot them out and I'm going to trigger an alert. So we can see, if their incoming port doesn't match 1237, trigger this alert, and then print out the icing on the cake here, the extra layered alert here. So it's that simple. That simple.
That's perfect. So that's two attacks, two defenses baked into one.
And so this is the user agent that you saw before, and this is how I'm doing it: is just curl-a, and then you type in what you want. And I'm using the user environment variable that it's just bash is going to have automatically, the hostname variable, and then up here I set up the SSH client environment variable. So and it's just an array where the first thing in the array is the IP address. I forget what the second is, and then the third, you can see here with number 2, is the port number.
That's perfect.
Yeah.
I really like that. That's so simple. And it just makes it really easy to immediately get the information you want from someone who's managed to log into this thing that they shouldn't log into, and then just boot them out before they can really do anything useful, as well as provide just enough clues to make them tempted to give up a little bit more information about themselves.
I've lost my mind. What's the directory we're looking for? Local. bin, and then nc.sh. So the way aliases work, aliases will actually be preferred before anything that comes in a path. So if we jump out here real quick and we do a which nc for netcat, we can see it's bin netcat, bin nc. So I could say file bin nc. It's a link, so this is the attacker's thinking. Maybe they're paranoid enough that they're looking for a trap beforehand. So they're chasing this around. They say, okay, let's take a look at, we can see there's some sim links. It's bouncing us around. Bounces us again. We're back in the bin folder again. And this is pretty typical on most modern Linux systems where you've got a bunch of sim links around, and that's just how it manages a lot of the software when you install it. But we can still see, we could even do an MD5 sum on this. We could check the hash. We can use the file command to see what type of file it is. If I remember how to computer. And we can see it's an ELF binary, doesn't look like a trap at all.
Right.
And this is going to check out 100%. But then when I go ahead and type netcat and it runs, I'm going to get an alert. And everything looks exactly like I'd expect it to look.
Right.
Yeah. But yeah, the trap still goes off.
So, and the trap here was actually embedded in the thing that looked like the regular netcat, right? At the very end, that thing that looked innocuous was the thing that actually was making the call.
Right, yeah. So what happens here is the alias comes first. It uses the alias first. And this alias is just it's gonna reach out, it's gonna generate that alert, and then it's gonna pass on the original arguments that were passed with that. So the command still runs normally. But
so it's very clever. So you could use that to exfiltrate, basically whatever the result of the previous command was.
Yeah, absolutely. Yep, and that's what we're doing right here with this with args. We're getting the full command that was sent before, and I'm trying to remember. Maybe I actually created these on separate consoles because I'm not seeing the result from that. But where's that? No, that's not it. So I'll have to figure out where I sent that off to.
The Oh yeah, I think it's probably in the whatever you set up when you did the demo that you wrote the
Yes.
bash script
So when
originally.
I wrote the blog, I changed it all because I wanted to use the free version to do it. So that's gone to my Thinkst account. That's where that's gone.
Yeah, so this is so cool because you can use the same thing to trap anything. Anything on your computer you want locked down or to at least be notified if someone's opening. You can set a trap on it, and you can either set an alternative that doesn't set off a trap, or you can just accept that the trap's going to go off when you access this thing that's maybe kind of dangerous and you don't want to yourself even be accessing that often. So it makes sense that this is a way that you could kind of like hide traps around your system just to make sure that the most important things or the most dangerous things on your system aren't being accessed randomly.
So here's where it went. We can see I ran netcat with the help as user Ubuntu on this host name, and I was coming from that IP address.
Wow, that's super cool. And that's just running a process that looks totally normal. That worked too. It didn't
Right.
do anything strange.
It came back, it did exactly what we expected it to do, and just brought us back to the prompt. Yeah.
Interesting.
So
Interesting.
unless you were paranoid enough to check the aliases that were set, you would have no idea. Because remember, when we type, and it's pretty normal. Like when I type which NC, that's where I expect NC to come from, but it doesn't in this case. It respects the alias over the path.
That's super cool and extremely sneaky. So I'm going to have to incorporate this into a human interface device attack. So stay tuned for that at some point because I think this is too clever to not kind of dig into a little bit further. We are out of time for today, so I definitely want to come back to this at some other point because just the potential of the DNS request triggers is so interesting to me that I feel like it deserves kind of a follow-up. But Adrian, thank you so much for walking us through these attacks that you can do. Well, I guess counterattacks that you can do using Canary tokens, both the variety that forwards to people, both the variety that forwards people to a link that makes sense, both the link, we went through so much today. Thank you for showing us the link that just goes to the blank page, the link that goes to the slow redirect, the link that goes to the fast redirect, and the DNS one that goes through even a type of Wi-Fi connection that might not be actually providing internet. There's so many different things here. I'm obviously getting a little bit
There's so many more
them,
we didn't even play with.
Like the QR codes, the
QR codes are fun.
AWS keys. There's just there's so much here that I'm kind of getting mixed up with them, but I'm gonna have to dig into some more of these, especially I think the DNS ones probably deserve their own episode at some point. So yeah, thank you for joining us today and walking us through all this. I hope that you'll come back again at some point. And I also want to mention thank you to Varonis for letting us do this show and bring on interesting guests like Adrian, who has the ability to show us these tools that I didn't know existed, but are free for anyone to try out. So if you're interested in actually trying out a Canary token yourself, they're free. You can put them everywhere, and you probably should because, there's some pretty wild stories with what people have discovered using them.
Why not? Why wouldn't you? Like it takes you a couple minutes and you're done. Just drop it in the root of C, drop it in your user folder, see what happens.
So if people want to generate their own, it's canarytokens.org/generate.
Yeah, you can just go to canarytokens.org and it drops right here.
Awesome. Cool.
And then if you want to run your own Canary Tokens server, you can come over to GitHub, and we've got everything you need to do that. If you want to run your own Docker, run it on, what'd you say your domain was?
Departmentoftoilets.gov.
That's amazing.
Thank you. Tim came up with that, actually. I can't take full credit for it, but
how do you have a
that's our Windows.
How does that work?
No, it's just locally. We just had to do DNS locally, and it's just like, should pick your DNS setting. So now it does resolve, but not to what you would expect.
Right, only in your network it resolves.
Yeah, only on our network, so yeah.
Okay. I was going to say.
No, if I'd managed to hack my way into getting a departmentoftoilets.gov, that would be my main email to contact me.
Yeah.
All right, cool. Well, that's going to be it for this episode of Hacking with Friends. Thanks again for joining us, and I hope you'll come back again another time to show us some more ways we can develop these into payloads, because I, for one, am super interested in ways that I could turn these into some interesting human interface device payloads.
Oh, thanks for having me. It's a lot of fun to play with this and to show it off, and I'm really eager to see what other people do with it. I love hearing the stories.
Cool. Well, if you guys are looking for some interesting payloads or some interesting applications for using Canary tokens, you should definitely check out Adrian, probably on Twitter. Or what's the best way to follow you?
Yeah, Twitter. Twitter's it.
Cool.
I'm very active on Twitter, and if you want to dig into some of these examples, we actually shared some code here in the blog post. You can just go to blog.thinkst.com.
Awesome. Cool. Well, hopefully you will have some new people that are coming up with innovative, cool ways, possibly creepy ways of using these tokens, and we'll be able to cover them in the future.
Awesome.
All right. Talk to you guys later. Bye.